Hey there, people out there. How you doing? Hopefully you're doing great. Maybe you're coming from my other video and you're going, hey, let me watch this next video. And you're just watching all my videos. Ton of videos today. I'm making a ton of videos today. But hey, let's go. Let's get into it. I don't know why. That's not even good English. I would like to do, today I'd like to talk about, and look at my background. I need to do something about this background. All this is a telephone and an air conditioner. That's exciting, isn't it? I'd like to talk to you today about measures of spread. So let's talk about like putting together all of our information that we're going to need to describe a distribution of quantitative data. Let's go and take a look at that. So suppose I have two places, McDowell's, and I know McDowell's. I don't want to use anybody's trademark, McDowell's from Coming to America, if you remember that, and Hot Dog King. I think I made that one up. I don't know if there's a Hot Dog King out there, but if there is, I'd like to know where. I like hot dogs. Okay, so let's suppose I have these two places, and a sample of their weekly salaries for their employees are here. Here's what I'd like you to do to really get the effect of this video. If you find the mean, median, and the mode, and then really quickly draw a dot plot or put this in a histogram and see what this looks like, and pause the video right now and just think about, decide with a partner, if you have a thought partner, let's just post it right here and talk to your partner. Think about which one of those would you choose just based on the average or the center here. We're talking mean and median, all right? So take a look at that and just think about which one you choose. And pause me right now. Pause myself. Okay, now that you're back, let's take a look at this. Now, you should have gotten something that kind of looks like this. Now, I've got McDowell's on the top and Hot Dog King on the bottom. Notice here that both of them are symmetric. So they're both symmetric distributions, and they both have the exact same mean and medians. So if I was a manager at either of these places and I said, hey, if you come work with us, you have an average salary of $320. Both of them would say the same thing. And you'd say to yourself, they're the same. What does it matter? I think I like hot dogs more than hamburgers. Lunch breaks will be better there. I'm going to go there. You can't make a full decision just based on, I guess you can make a decision based on your tummy, right? But really what you need to do is you need to have the third piece of information. Yes, it's symmetric. Yes, they both have mean and medians that are the same. But can't you see that there's definitely a difference between these two places? In fact, one of them is more spread out than the other one. We see the data are really close together of $320 in McDowell's, but the data are very far apart and spread. They kind of spread and have a larger range here for Hot Dog King. So, someone might say, well, I feel like I can earn about the average more consistently. Like I won't be stuck at like $300 for the whole time. I'll be around the average at $320. But so I'll pick McDowell's. Or somebody might say, well, I have a chance of getting $340, so maybe I'll pick Hot Dog King. But in order to really make a sound decision, we need three pieces of information. Minimum here, we need the shape, the center, and what we call the spread, or the measure of variability in the data. So there are statistical ways to measure that variability. Here they are, or variation. So how do we measure variation in the data? And I already have apparently I have a formula up there that is for S. I wonder what that means. So the first thing is the range. The range is the max minus the min. In statistics, a range is a value. So please, if you're in my class, don't put that the range is 300 to 340. That's not the range. That's an interval. I would like the value. And the way you do that, you subtract. So the range of McDowell's is going to be 20, and the range of Hot Dog King is $40. All right, it's one number. What else can you do? You can describe the measure of variation by the IQR, which is called the interquartile range. Think of it as the middle range. It's the first quartile, which is the 25th percentile. The third quartile, which is the 75th percentile. You're going to subtract those numbers, and you're basically going to get the middle 50% range. So this is great because it doesn't take on out like the range. If you have two really big outliers, but most of the data are right in the middle, then you're going to end up with this whole big, I don't know if you can see my hands, or you're going to end up with this whole big range when really that doesn't really explain the real spread of the data are right clumped in the middle. So the IQR will only look at the clump in the middle and not worry about these really far guys. You can't see me, but I'm doing spirit fingers right now. Spirit fingers. Okay, so that's the IQR. I probably use the IQR more often than I use the range. The other is the variance, and the variance we get when we look at the square deviations. Basically, what we're doing is this is basically the average square deviation. What is that? What the heck does that mean? That means I'm looking at all my data and I'm seeing how far those data are from the mean, from the center, the average. I'm looking how far those are. Then I'm going to square that so I can find the square distance, because I don't like to have negatives. And then I'm going to divide by the number of terms -1, and that's going to give me the variance. If I square root the variance, which is what I have there in this formula, I get what we call the standard deviation. This is the one of the big guys that we use to measure variation. So how do we use the standard? Excuse me. How do I just pause for no real reason in that right now? Why would we use the? So when do we use the standard deviation? What is it? Now, I'm not going to show you how to calculate it, although there's the formula, but really think about it as basically the average distance to the mean. So what I'm really looking at is, like, on average, how far away are my data from the center? If on average they're far away from the center, so a big standard deviation, then I have larger variability, larger variation. The spread is going to be larger because the data are, on average, further from the center, specifically the mean. If my standard deviation is smaller, then I can see more consistency in my data. They're going to be clumped, consistency around the mean. This is important thing is that we are using the mean to calculate the standard deviation. So what does this all mean? Get it? So what are you going to do? When you describe your data, when you describe when you describe a distribution of quantitative data, which I'm going to make another video on that too and show you how to write this out. But when you describe your data, you want to use your range and your IQR when you have skewed data, because the measure of center that we use for skewed data is the median. And I talked about this on a previous video, that the mean is pulled by the outliers. So we want to use the median to describe skewed data. But when we have symmetric data, we're going to want to use the standard deviation as our measure of variability or variation. So we are going to use the standard deviation and the mean because they go together like peas in a pod. All right, those are measures of variation. And that's really all I have to go over on this one. Next video I'll do is how do we describe it in sentences. Catch you later, guys.